Good evening. I'm Steve May with the Federal Aviation Administration. Tonight we will provide an update on the Southern California airspace modernization, more specifically, the Southern California Metroplex. I am joined by Rob Henry, Southern California Metroplex Project Manager, and Jose Gonzalez, Southern California Metroplex NATCA Co-Lead. The airports we will be focusing on tonight will include San Diego International, McClellan Palomar, Brown Municipal, Navy North Island, Montgomery Gibbs Executive, Gillespie Field, Ontario International, and Palm Springs International Airports. The procedures that will be implemented on the March 2nd and April 27th chart publication dates will be our focus for tonight's presentation. Fundamental to meeting the overall next-gen air traffic management, there has been and still is the need to evolve air traffic to a time-based system. An aircraft must be capable of receiving dynamic and complex instructions from ground systems that identify where they need to be and at what time. This requires the FAA to implement digital communications, leverage advanced navigation performance and flight management systems, and design and implement new airspace and procedures. Once NextGen is fully implemented, we will be able to identify the location of each aircraft at any point in time along the way to its destination. This will have a tremendous impact on our ability to manage air traffic more safely and efficiently. Looking at the Southern California Metroplex study area, the study area covers a large portion of Southern California, from Santa Barbara to Palm Springs and down to San Diego. It includes 6 major airports, including Bob Hope Airport, Los Angeles International Airport, Long Beach Airport, Ontario International Airport, San Diego International Airport, and John Wayne Orange County Airport. There are also 15 satellite airports within the study area. The goals of the Southern California Metroplex include improving flexibility and predictability of air traffic routes through increased use of performance-based navigation. The improvements will be achieved by utilizing satellite technology and publishing and implementing advanced procedures. Tonight we will look at several procedures including area navigation, abbreviated as RNAV, standard terminal arrivals, abbreviated as STARS, standard instrument departures, abbreviated as SIDS, required navigation performance approach procedures, abbreviated as RNP, and optimized profile descent, abbreviated as OPD. Area navigation is a method of navigation that mitigates the limitations of an aircraft navigating from one ground-based navigational aid to a satellite system providing point-to-point operational capabilities. Standard terminal arrival route is a specific repeatable path with lateral and often vertical descent guidance for arrivals to an airport. Standard instrument departure is a specific repeatable path with lateral and often vertical climb guidance for departures from an airport. Required navigation performance, or RNP approach, is an approach providing a higher level of precision than an approach using ground-based navigation. And finally, optimized profile descent is a procedure that keeps arrival aircraft at cruise altitudes as long as possible before beginning an uninterrupted descent. Once begun, the procedure departs from the usual pattern of stair-step descent all the way down to landing. We took a phased approach to executing the Southern California Metroplex project. We started out with study team phase, which completed in December 2011. This phase included potential opportunities and operational issues were identified to determine if a benefit could be developed through the application of performance-based navigation procedures and airspace changes. These designs were highly conceptual. The next phase was the design team phase and was completed in March 2014. This phase was used to refine the study team recommendations and conceptual designs into final, implementable, performance-based navigation procedures and airspace designs. And the next phase was the evaluation phase, which was completed in August of 2016. Within this phase, the proposed procedures were evaluated to determine if they met operational, environmental, and safety requirements. The final phase is the implementation phase, which began on August 31st, 2016, and is currently ongoing. After issuance of a finding of no significant impact record of decision, activities in this phase are to complete and execute the implementation of the procedures developed during the previous phases.
Good evening. I'm Rob Henry, Manager, SoCal Metroplex. Let's begin our procedure discussion with departure and landing direction, or runway in use. Wind direction and velocity are key factors used to determine departure and landing direction. Wind speeds below 5 knots is negligible. Runways are typically identified by their runway magnetic direction. For example, the West Flow runway at San Diego International Airport, or SAN, is 275 degrees magnetic. The last digit is dropped and it becomes San Diego runway 27. The rationale for operating into a headwind is simple. More wind flowing over the wings provides more lift at lower ground speeds. A tailwind makes an aircraft faster across the ground, requiring more runway length. Southern California airports typically experience westerly winds, which favors west operations. Two terms you're going to hear a lot when we talk about satellite-based routes are optimized profile descents and optimized climb profiles. Here's how they work. First, the optimized profile descent. Please notice the dotted blue line. This represents current flight operations. A traditional ascent is like walking down a flight of stairs. Based on air traffic controller instructions, the pilot descends and applies speed brakes, then levels off and powers the engines up, then descends and applies the speed brakes again. The cycle repeats itself until the airplane is on its final approach to an airport. Please note the solid blue line. It represents the optimized profile descent. By contrast, the optimized profile descent has built-in speed and altitude restrictions at various points along the route. These restrictions are designed to provide automatic separation from aircraft on other routes by either vertical altitude separation or lateral distance separation. This information is programmed into the airplane's flight computers and allows the aircraft to glide down to an airport at near idle power. Air traffic controllers no longer have to issue instructions after clearing the plane to begin its descent. OPDs are safer in that there is less pilot-controller interactions. Airplanes flying OPDs versus traditional descent generate less noise and emit less pollution because their engines are at near idle and speed brake use is minimized. Please note the yellow area on the chart. The yellow area depicts a dispersed vectoring area. Current arrival procedures utilize ground-based navigation and radar vectors. Controller vectoring creates high workload for air traffic control and flight crews. Vectoring creates inconsistent flight paths, creating wide dispersion areas for arriving traffic. Vectoring also provides for inconsistent vertical profiles as altitudes are assigned by air traffic control. Arrival procedures are not connected to approaches. In this example, 2 arrival routes, or stars, are connected to the RNP. Star approach connectivity provides for repeatable and predictable flight paths. It simplifies operation for flight crews and air traffic controllers. It allows for use of flight deck automation and provides for a stabilized and efficient approach operation. A traditional climb profile is like walking up a flight of stairs. Based on air traffic control instruction, the pilot climbs and then levels off and powers the engines up and then climbs again. The cycle repeats itself until the plane is at its final cruise altitude. By contrast, an optimized climb profile has built-in speed and altitude requirements at various points on the route. These restrictions are designed to provide automatic separation from aircraft on other routes. This information is programmed into the aircraft's flight computers and allows them to climb at optimal power, and controllers do not have to issue instructions after clearing the plane to climb. An optimized climb profile is much more efficient than traditional climbs and is a key benefit that we are seeing today from our use of satellite-based routes. Optimized climbs are safer due to less pilot-controller interaction. Airplanes flying optimized climb profiles versus traditional climb generate less noise and emit less pollution. The benefits that we are seeing from this operations are reduced air traffic control task complexity, reduced communications between the flight deck and controller, reduced phraseology, reduced frequency congestion, reduced pilot workload, repeatable and predictable flight paths, accurate fuel planning, and laterally or vertically segregated flows.
Let's take a look at the National Environmental Policy Act. The Southern California environmental assessment process began with study team participation in November of 2011. The draft environmental assessment was released on June 10, 2015, and the public comment period was open for 120 days. The finding of no significant impact record of decision was signed on August 31, 2016. And the final environmental assessment is available on the Southern California Metroplex website. We will provide the website information to you towards the end of the briefing. The finding of no significant impact record of decision enables the agency to move forward with replacing dozens of existing conventional air traffic control procedures with new satellite-based procedures. FAA began phasing in the use of the procedures starting in November 2016 and continuing through April 2017. When the Southern California Metroplex procedures are implemented, some people might see aircraft where they did not previously fly. This is because some air route changes will occur and because satellite-based procedures create more concentrated flight paths than conventional procedures. Some people will experience noise decreases or increases, and some will experience no changes at all. Some flight track dispersion will continue to occur after the new procedures are implemented because the Metroplex project includes a number of existing procedures. Also, air traffic controllers will need to occasionally vector aircraft for safety or efficiency reasons, or to reroute them around weather systems. The following noise maps are created to enhance the understanding of all potential noise changes in the study area. Please note that many of these changes occur at noise levels at or below the noise level experienced in everyday living situations in the area. The noise maps represent noise changes of DNL plus or minus 1 decibel. For many people, the small change is difficult to distinguish. The FAA DNL metric is a value representing the aircraft's sound level over a 24-hour period and includes all of the sound energy generated within that period. The DNL metric includes a 10 decibel weighting for noise events occurring between 10 p.m. and 7 a.m., which we considered as nighttime noise events. The FAA did not use these maps for decision purposes. The noise maps are provided for disclosure purposes only. This next slide looks at increase and decrease in DNL at or above DNL 45 A-weighted decibels or dBA. In the map, you will see a blue shaded area. This represents the DNL decrease. You will also see a green shaded area which represents the DNL increase. The bold line around the Southern California area is the general study area boundary, and the small lightly shaded polygons are community or city boundaries. The 45 and above decibel noise level map is provided based on FAA's established criteria for changes in noise levels. This next map looks at increase and decrease in DNL at or below DNL 45 dBA. Once again, the blue denotes DNL decrease and the green denotes DNL increase. And again, you will see the general study area boundary and the communities and cities within the general study area. Although there is no established FAA criteria for changes below 45 decibels, this map displays those changes to enhance the understanding of all potential noise impacts in the study area and is provided for informational purposes only.
Let's look at community engagement next. Southern California community engagement began with early notification of the EA on January 21, 2014. The FAA conducted 11 public workshops from June 16th through July 1st, 2015. The workshops were conducted in Santa Ana, Santa Monica, Los Angeles, San Diego, Palm Springs, Torrance, Long Beach, Ontario, Ventura, Santa Barbara, and Burbank. The FAA extended the public comment period for a total of 120 days. The comment period closed October 8, 2015. Approximately 4,000 individual comments were received. Approximately 2,700 unique comments or form letters were received. Approximately 380 comments were received after the public comment period closed. However, these comments were addressed in the environmental assessment. Approximately 570 comments were received from 3 online community work groups. Responses to comments are included in the environmental assessment. Based on community comments, the FAA reviewed all procedures. Our analysis consisted of reviewing the following. First was safety. Will the change have an adverse impact on safe operations? The team considered aviation safety information analysis and sharing data with potential impact to airspace, procedures, and enhancement of safety. We looked at traffic collision avoidance system hotspots. Next, we looked at terrain avoidance warning system alerts. And finally, we looked at high energy descent and approach events. Next, we looked at efficiency. Will the change create substantial inefficiency in the procedures? Next, we looked at complexity. Will the change increase workload beyond a reasonable level for controllers or flight crews? Next, let's look at the March 2nd and April 27, 2017 procedural implementation. This chart shows the procedures that will be implemented for the airports beginning on March 2nd, 2017 and April 27, 2017. Let's begin with McKellen Palomar and Camp Pendleton. Before we begin, let's look at the chart and look at the upper right corner of the chart. You will notice an insert, and the insert shows some light blue lines proceeding into the airport. These are actual flight tracks to the airport. Next, you'll notice the orange lines. The orange lines represent the stars or terminal arrival routes into the airport. You can also notice the highlighted yellow area. This is the environmental assessment dispersed path area that was evaluated. Moving to the larger map, again you'll notice the orange stars indicated with the arrow of the Lagos star. The Lagos star proceeds inbound to Lagos, which is a satellite waypoint indicated by a white star. Continuing to the star, you'll notice the next satellite waypoint, Brinks. It also has an altitude associated with that waypoint. It's at or below 13,000 feet. And then you continue on the star to the airports. The Lagos one serves Palomar and Camp Pendleton airfields. They serve arrivals from the north and northwest. The Metroplex team determined that traffic over the Los Angeles airport and VORTAC was too dense, and as a result, 2 transitions were designed. The western transition of the star will be assigned to aircraft operating at or above 50240 to mitigate conflicts over Los Angeles and provide a descent area for Palomar arrivals. This will typically be Ched aircraft. The eastern transition will remain over Los Angeles and be utilized for a lower volume of traffic operating on this route below flight level 240. Our design was constrained by interactions with Los Angeles arrivals and Orange County departures. Ontario Airport. The Eagles 1 serves arrivals from the northeast. The design was impacted by interactions with other procedures and terrain. Altitude restrictions were added to reduce complexity with the Long Beach, Orange County Disney, and the Ruby Stars. The design segregates Ontario arrivals from Los Angeles Angel Star and the Burbank, Santa Monica, Van Nuys, Copal Stars. The star ties into the new Ontario RNP approaches. The Ontario Scooby Star replaces the Ziggy Star, which is a conventional procedure relying on ground-based navigation. The Scooby Star serves Ontario arrivals to runway 8 left and right and runway 26 left and right from the east and southeast. The design was impacted by interactions with Burbank, Slap Sid, and the terrain. Design reduces interaction between simultaneous Ontario, Long Beach, Orange County, or Palm Springs arrival by increasing the lateral and vertical distance between aircraft arriving at these airports. The star ties into the Ontario RNP approaches. The Ontario Carls B 1 Star. Currently, there are no published arrival procedures to Ontario for aircraft from the west. Carl B1 allows aircraft to be as much as 7,000 feet higher over Catalina Island. OP designs were impacted by interactions with Los Angeles and Orange County departures, as well as San Diego and Palomar arrivals. The Ontario Glarner 1 replaces the current Ziggy Star, a conventional procedure relying on ground-based navigation. It serves all Ontario arrivals from the west and northwest. Our design was impacted by interactions with Burbank, Slap Sid, and terrain. The Glarner 1 Star ties into the Ontario RNP approaches. The Ontario RNP runway 8 left, 8 right, runway 26 left, and 26 right RNP approaches will provide a more predictable and repeatable path, reducing complexity and increasing safety and efficiency for Ontario arrivals. The new Metroplex stars will tie into the approaches. This air traffic control sign approach will be flown by properly equipped aircraft with qualified crews. The Ontario Sunshine 1 SID serves the Ontario departures to the northwest, north, and northeast from Ontario runways 8 left and right, and runway 26 left and right. Current procedure is inefficient and conventional SID dependent on ground-based navigation. The Sunshine 1 star is deconflicted from the Los Angeles arrivals in the Southern California TRACON airspace. Provides independent and segregated route structure after departure, allowing for more unrestricted climbs. And I want to clarify, this was a SID, not a star. The Raji 1 RNAV SID serves departures to the east, south, and west from Ontario, runway 8 left and right, and runway 26 left and right. It closely follows historical track data. It maintains lateral separation from military airspace, restricted airspace 2503. Palm Springs, Bermuda Dunes, and Jacqueline Cochran Regional Airports, thermal. Currently, there are no RNAV procedures to these airports for aircraft landing from the northwest. The star connects to the Palm Springs runway 13 right RNP approaches. It reduces complexity with more predictable and repeatable paths. The altitude restrictions deconflict from the Los Angeles Angel Star, and the star deconflicts from aircraft on the Ontario Galarno, Eagle Star, and the Long Beach and Orange County Ruby Star. San Diego and our San Diego satellite airports. The San Diego Playa 1 RNAV star. The current Shamu arrival will be replaced by the Playa. It's an inefficient conventional star dependent on ground-based navigation. The Playa star is an RNAV star. It serves runway 9 arrivals from the northwest. It allows aircraft to be as much as 3,000 feet lower over the ocean, reducing the excessive rate of descent and the vectoring currently required. It allows for holding of runway 9 arrivals while runway 27 aircraft depart during opposite direction operations. The San Diego COMEX star connects the San Diego runway 27 RNP approach. It serves arrivals from the northwest. The RNAV procedure has OPD benefits. It's deconflicted from the Los Angeles Panda and the Tusty SIDS. Additionally, it's deconflicted from the Los Angeles OLA star. The San Diego Top Gun 1 RNAV star serves arrivals from the east and northeast landing on runway 9. The design deconflicts San Diego arrivals and departures inside Southern California TRACON airspace. The design of the San Diego Top Gun star and the San Diego SEO SIDS were constrained by Mexican airspace and military airspace restricted area 2510. This procedure provides a more consistent downwind leg prior to entering approach for runway 9. The San Diego Departure Echo RNAV SID runway 27. Echo SID serves runway 27. It is deconflicted from the Los Angeles OLA star. It reduces interactions between the San Diego departures to the northwest and San Diego arrivals from the northwest. It complies with Southern California TRACON directives on departures. The Moto 1 RNAV SID serves runway 27. It is an RNAV departure procedure. The lateral path was established to maximize efficiency for the San Diego Echo SID departures and surrounding traffic flows. This procedure was developed for traffic routed over the Pacific Ocean and initially follows the same path as the San Diego Echo SID. The Moto 1 SID complies with Southern California TRACON directives on departures. The San Diego and Satellite Seaward 1 RNAV SID transitions were established to closely mimic historical tracks. For traffic departing San Diego and the satellite airports in San Diego area for destinations within the Southern California TRACON terminal airspace of responsibility, the altitudes are assigned by air traffic control. Inclusion of satellite airports will reduce complexity for both air traffic controllers and users by providing a more repeatable, and predictable path for satellite airports. The San Diego Padres 1 SID actual flight tracks did not follow the current procedure departure as flown. Transitions were established to closely mimic historical tracks. The traffic departing San Diego and satellite airports in the San Diego area for destinations beyond the Southern California TRACON terminal area. Altitudes are assigned by air traffic control. Inclusions of satellite airports will reduce complexity for both air traffic control and user by providing a more repeatable and predictable path for satellite departures. The SoCal 1 RNAV SID is for Runway 9. The Metroplex designed Top Gun Star and SoCal SID have minimal space between the Mexican border and Military Airspace Restricted Area 2510. This limits route segregation. The design mitigates some interactions in Los Angeles Center airspace between the Top Gun Star and the SoCal SID that will be more manageable than current conditions. Procedures will separate San Diego inbound and outbound flows in Southern California TRACON airspace. The T-Route is an RNAV airway. T-Route 326 was developed for the current Victor 66 airway traffic, which are often in conflict with the San Diego arrivals from the east.
General project information. This briefing is for informational purposes and does not reopen the Southern California Metroplex environmental. Any noise issues should be directed to the appropriate noise office. Information about the Southern California Metroplex project is available on the Metroplex website. This presentation will be available online on the website. Additional public information. Before publishing the procedures, the agency is conducting public information meetings and webinars to further inform people about the changes. The FAA will notify the public through press releases and on Facebook, Twitter, Instagram, the Metroplex website, and possibly other additional platforms. The currently scheduled community engagement is highlighted in the following table. Note that this presentation is one of the 4 listed internet-based webinars, and that in the following weeks we will conduct a total of 12 community informational briefings. Please refer to the Southern California website for times, locations, and content for each of the community informational briefings. And now for the Southern California Metroplex website information. The first link indicates the Southern California Metroplex Environmental Assessment website. This is the main web page for the website, and all other web pages can be found by navigating to this page. For specific information, we noted the frequently asked questions and the various environmental assessment documents and Google Earth files. Additionally, the Environmental Assessment Appendix F contains the FAA responses to public comment. Due to the large size of this appendix, it was broken down into 3 files. Each of the 3 volumes is available on the website using the following URLs. Once again, this presentation will be made available on the website. This concludes our formal presentation, and we will now move to the questions and answer portion of tonight's webinar.
Steve, we had a couple questions come in during the presentation. The first question started with a statement and said, "This is good information, but where can I get more information on the procedures?" It's a great question. More information can be found on the FAA website. The FAA is also providing 10 public workshops starting next week throughout different communities in Southern California. Our FAA subject matter experts will be available to explain procedures in depth and answer the questions, and we invite the public to attend our workshops.
Thanks, Rob. I got a couple questions. The first one, is the FAA taking into consideration comments that I may have, and if so, how do I submit them? A public comment period was provided during the draft environmental assessment phase of the project. This was provided in the summer of 2015. The FAA evaluated and responded to more than 4,000 public comments received during the 120-day public comment period, and the final EA was issued in August of 2016. So these comments and all project documents can be found on the Southern California Metroplex project website at metroplexenvironmental.com. The next question I have, how can I find out more information about noise in my neighborhood? Going back to the EA website, which has detailed instructions on how to determine noise changes on the Google Earth.
Steve, the next question I had is, will the FAA be monitoring the effectiveness of these new procedures? The answer is yes. The FAA monitors deviations from expected flight paths during the implementation process, according to FAA orders. During this phase, the procedures are observed to ensure that they perform as expected and meet the purpose and need of the project. The next question we had was, who can I report noise issues to? For noise issues, contact your local airport management.
All right, thanks, Rob. I have a few more here. First one, have these new routes already been implemented? Some procedures were implemented in November, but all the procedures discussed during this evening's presentation will be implemented on either March 2nd or April 27th. Next question I have, will there be more webinars prior to April 27th implementation? Currently, there are no plans for further meetings or other informational briefings other than those listed in this webinar. The next question I have, are you increasing the capacity at Lindbergh Field? The FAA does not determine capacity or flight schedules for any of the airports in the presentation.
Steve, I had two remaining questions. The first one, are the new San Diego departures in compliance with existing noise abatement procedures? The answer is yes. The new procedures were designed to remain within existing historical flight tracks. No changes have been made that would affect local noise abatement procedures. And the final question was, who do I talk to about airport curfew hours and violations? We recommend you contact your local airport management office with these concerns. And Steve, that's the last question we had come in.
All right, well, I'd like to thank Rob and Jose for helping out with the presentation tonight. This will conclude our webinar presentation for the evening, and we thank all of you for joining in and for making the Southern California Metroplex project a success.